Welcome to Kojo's Math, and today we're going to be talking about solving proportions using the cross products property. Now, this is a property which means that it will work for any problems for any numbers. And it's a property that you'll use again and again. We're going to use this one for proportions. Remember that proportions are two ratios that are equal to each other. It could be two rates that are equal to each other. And we can always find a missing part of the proportion by setting up a ratio, two ratios to equal each other. And then we'll use the cross products property. So the cross products property says that, here it is, this is the cross products property. A to B equals C to D. Now we learned the other day that that would be similar fractions. Okay, so 1/3 equals 2/6. See how that works? 1/3 equals 2/6. And if I had 1/3 equals how many sixths, then you know that you would just say, well, 1/3, 3 goes into 6 twice, so 1 times 2 is 2. So 1/3 equals 2/6. Here, when we use the cross products property, it's when the two fractions that are similar don't go in evenly. So we have to find another method to find the missing part, the numerator, the denominator, or we have to find another method to prove that it's true. And we do that using the cross products property. So here we go. We have A to B equals C to D. And I said the word 2 because we're going to talk about two ratios. The cross products property says that if I multiply the numerator of one fraction times the denominator of the fraction of the other fraction or ratio, and I set it equal to, see I have A times D, it's equal to if I multiply the denominator of the first ratio times the numerator of the second ratio. So B times C or C times B. It doesn't matter what order you put them in. I could say D times A or A times D equals C times B or B times C. But it says that when I say A times D, that's AD, and C times B is CB or BC, it doesn't matter. That they're equal to each other. So sometimes I'll give you two ratios and say, are they proportional? And the way you do it is you use the cross products property to prove it. You would say 4/5 equals 12/15. And using the cross products property, you show your work by saying that numerator of the first times the denominator of the second, 4 times 15, and you have to write this step, times the denominator of the first times the numerator of the second, 5 times 12, and you set them equal to each other. So you bring down your equal sign. You must show this step, and you must show it horizontally, directly underneath the problem. So see, that's the first step, is to write the problem. The second step is to write the cross products multiplication. You're showing your work. And the third one would be is 4 times 15 is 60 equals 5 times 12 is 60. See the steps? 1, 2, 3. 3 steps. This shows that these two fractions or these two ratios are proportional, meaning they're equal to each other. Now there'll be times, though, when they're not equal to each other. So we have 2/3, this is a 3, equals 4/5. Using the cross products property, the numerator of the first times the denominator of the second, and see how I connect them? 2 times 5, I write down 2 times 5 underneath it. Then the denominator times the numerator, 3 times 4. Bring down the equal sign. Then I say 2 times 5 is 10, and 3 times 4 is 12. These are not proportional. These two ratios are not proportional. They're not similar. And that's how you would prove it. Well, you're going to go, oh, when do we use this? Do you guys see my new addition? This was the surprise. This is Mrs. Owl now. Remember, Mr. Owl was flying to Cranbrook, and he never made it. Well, he met up with Mrs. Owl, who is from Cranbrook. As you can see, she's blue and green, our school colors. And they decided to come back here because Mr. Owl liked his digs better than hanging out at Cranbrook. Go figure, he likes being at my house better. So Mr. and Mrs. Owl. Go figure. Yeah, they're pretty happy here. They like it. I like them. I like having them hanging around. So here we go. So we're going to look at the next thing. Oh, notice one thing I wanted to show you. When we're showing our work for the cross products property, look, when we connect them, they make giant time signs. Because that's just a little reminder that you have to multiply using the cross products property. Okay, here we go. So here's how we use it. X to 12 equals 18 to 27. And I need to know what X is. Now, hopefully you can see that sometimes, based on what you did for homework the other night, 18/27 always simplify where you can to make your life easier. 18/27 simplifies to 9 goes into both, so what does it become? 2/3. Now, the way you did the homework the other night, you should know what the answer is because 3 goes into 12 4 times, so 2 times 4 would be 8. Unless I say use the cross products property to find X, in which case we multiply the numerator times the opposite denominator, so we get X times 3 equals the denominator times the opposite numerator, 12 times 2. We have to show this step. Yes, you do. You have to show that step or you'll make a lot of careless mistakes. That's showing your work. Now, so 3x times 3 is 3x. You could write x3, but we write 3x. We get rid of the dot. 12 times 2 is 24. Now, what times 3 will give us 24? 8. But you got to show it. So what you're going to do, if we're multiplying, how do you undo multiplication? Yeah, you divide. So we're going to divide this by 3, and we're going to divide this by 3. Because whatever you do to one side of the equation, you must do to the other side of the equation. Well, the 3's cancel, and we're left with x equals 8. So x equals 8 is our final answer. But that was a situation where we could have said, originally we had 18/27, so don't forget that. And we simplified it to 2/3. But here we have 36/24, and I'm going to simplify it. I can use a calculator on these. My calculator's right behind me. It's right there. You could use a calculator if you liked, but you don't have to. You can use, okay, I'm going to simplify 36/24, or I could multiply and do the cross products property, but 36/24 simplifies, 12 goes into both, so it simplifies to 3/2. Now using the cross products property, numerator to opposite denominator, I have to write my step. 3 times 15, denominator to opposite numerator, 2 times x. I have to write my step. 3 times 15 is 45, and 2x. How many times does 2 go into 45? What times 2 will give us 45? Well, it's 22.5, but you got to show your work. So how do we undo multiplication? We divide both sides by 2. X equals 22.5. Yes, you can use a calculator for these. It's okay. Now, you're going to use it when you're going to also use proportions and ratios with figures. And this is getting you ready for similar figures and scale drawings when we're going to draw a representation of something really, really small and we blow it up like a cell. Or where we're drawing something to scale that's a car and we want to make a smaller picture of it. We're going to draw something. So when we do that, we have to compare. This is a small rectangle to a large rectangle. So we compare the sides that correspond to each other. So this is the width on this one, and this is the width on this one. So we're going to compare these two sides, and we're going to write them as a ratio. So 35 to 60 equals, because we got to write two ratios because we're writing a proportion. So this is the length of the small rectangle to the length of the larger rectangle. And I'm going to put 2 notches to show which ones I'm comparing so I don't get confused. So I write the ratio of the small rectangle's length to the large rectangle's length. So I write 42 to 72. So now you simplify, that's my phone, you simplify 35/60ths. What goes into both? 5. So this simplifies to 7/12, or 7 to 12. And then we're going to simplify 42 over 72, or 42 to 72. 6 goes into both of those. So when I simplify that fraction, I get 7 to 12. If these two fractions or these two ratios are equal, then this figure is proportional to this figure. In order for them to be proportional, the ratios of each sides in comparison have to be equal. This small side to this small side is 7 to 12. This length to this length, this small length to this large length is 7 to 12. That means for every 7 units on this width, this one goes up 12. So if this one goes up 14, then this one would go up what? 24. If this went up, same thing. If this went up 3 7s to 21, then this one would be 3 times 12, which is 36. They are proportional. So it would be a scale drawing. I could make this. This is a scale drawing of this. There are times when you look that they're not proportional, and we will talk about that in the future. So right now, I want you to write down 2 things that you've learned and 1 question you still have. Yes, you must do this, and I will see you in class. Bye-bye.